Before we get started on graphing in standard form, let's just remember the form that we do know. We do know vertex form. We just got finished taking a test on it. Vertex form is y equals x minus h squared plus k. Standard form is y equals ax squared plus bx plus c. Today in class, everyone should have done a cooperative learning activity that showed you how to find the vertex in standard form, going from a vertex form to standard form. So let's just go over that real quick, and you will need to know this. The formula that you found was x equals negative b over 2a. That finds the x part of the vertex, and then f of negative b over 2a finds the y part. Now remember, I know this looks fancy, but this just means the function evaluated at whatever you got here. Okay, so we're basically taking this, saying evaluate means plug in. For x. So if I were to write this as an ordered pair, the vertex in standard form is going to be negative b over 2a to find the x, and the function evaluated at negative b over 2a. That's going to be my y. So this is the x, this is the y. So let's look at graphing a quadratic function in standard form. The first thing I'm going to do is label my a, my b, my c. What is my a? What is my b? What is my c? My a is 1, my b is 4, my c is negative 5. Please remember, your a does not include the x squared, your b does not include the x. It is the number in front of the x, so positive 4. It is the constant at the end, so negative 5. Okay, the next step we're going to do is we're going to do x equals negative b over 2a. And I like to just say the opposite of b over 2a. So the opposite of my b is negative 4 over 2 times plug in that a. Notice I'm always going to plug in parentheses, and I'm going to get negative 2. So I get x equals negative 2. And we're going to look at that in a minute to see what that is. I want you to think about what that is while we continue on what we did today. We're going to take that x and we're going to plug it in. So y equals negative 2 squared plus 4 times negative 2 minus 5. And I'm going to get y equals 4 minus 8, negative 4, negative 9. So I know that I have the ordered pair, negative 2, negative 9. And that is going to be my vertex. When I make a table, I am going to put that vertex right dead in the center. Okay, now the next thing I want you to see is that if I plot negative 2, negative 9, the point's going to be right there. And we all know, because we've done this in vertex form, that this is my axis of symmetry. And I know, because it has to be x equals the x, that what I first found was the axis of symmetry. So this axis of symmetry is x equals negative 2. And on every graph, we expect to see you put in the axis of symmetry. All right, now that I have that, there's one more really cool point that makes me not have to do that much work, and that is this number right here at the end. This number right here at the end, in standard form only, is going to be my y-intercept. Why is that? Because I know my y-intercept is always 0, a number, And if I plug 0 into this x and this x, I'm going to end up with -5. So I know my y-intercept is going to be 0, -5. And because this axis of symmetry, I have points that are symmetrical on either side, since this point is 2 units to the right, I know, as in vertex form, that I have one 2 units to the left. So I'm going to plot both of those. And notice I also added it onto my table. This is going to be -4, -5, so I'm going to add that onto my table also. Okay, last thing I have to do is plug in another point. Now let's think of a good point to plug in. Do I want to plug in 4 or -8? Because these, if you can follow this, are going to be way up here somewhere. Okay, I want to plug in another point on either side of my axis of symmetry, right in here close. Okay, so I'm going to plug in -1. And if I plug in -1 into my original function, so I'm going back to the original and I'm plugging -1 in here and -1 in here, I would get -1 squared is 1, -4 minus 5. So if I plug -1 in, I'm going to get -8. And symmetrically across, I'll have one right there also. So -1, -8, and -3, -8. And now all I have to do is connect my parabola. Okay, that's graphing a parabola. Now, I don't know how accurate my x-intercepts are here. And we know that x-intercepts are pretty darn important in parabolas, quadratic functions. So I'm just going to put that on hold. Just know that these are probably not that accurate. 2, 3, 4, 5. Okay? So let's try another one. And I want you to notice that from the vertex, I could actually tell if it was reflected, I could tell if it was stretched or compressed, I could tell if it was shifted left or right or up or down. I can still tell some of those things from standard form because this is my A. Okay, my A value, this is reflected and stretched. Okay, this is my C value, so this means I've moved down too. So you still can tell a lot about what the quadratic should end up looking like. This is my y-intercept, -2. So let's go ahead and I want you to fill in what the A, the B, the C is. And if you put down -6, -12, and -2, that would be my A, my B, and my C. And now what I'm going to do is the first thing I need to do is I need to find my axis of symmetry, the x of my vertex. And I know the axis of symmetry is x equals -b over 2a, or the opposite of b over 2a. So the opposite of my b over 2 times my a. And this is going to give me -1. And I'm actually going to go ahead and put that in. Don't forget that the axis of symmetry is actually an equation. It is not a number. So if I ask you for the axis of symmetry, you must give me the equation of a line. And this is, there we go. Okay, now the second step is I want to find the vertex. And remember, I know it looks crazy, but the vertex is -b over 2a, and the function evaluated at -b over 2a. So right now, I know the x of the vertex is -1. Just moved my screen, sorry about that. -1. And I want to plug it in to find out what my y is. So I know that y equals -6. I'm going to plug in my -1 and square it. -12. And again, I'm going to plug in my -1. And -2. Okay, so this y is going to end up being -6 plus 12, which is 6, minus 2 is going to be 4. So that will end up being the y, -1, 4 of my vertex. And I now have my vertex. Okay, So again, I'm going to create that table. And I'm going to put -1, 4 right in the middle. I know my axis of symmetry is x equals -1. I know my y-intercept. Don't forget, my y-intercept is always this number right here. If I plug in 0 for x, I'm going to get -2. So my y-intercept is 0, -2. And I know I have a point symmetrically on the other side of the axis of symmetry. Now I'm just going to plug in +1. So if I plug in +1, I'm going to get -6 minus 12 minus 2, which is way down there. That's not going to work very well, is it? Well, let's plug it in and plot it down there somehow. So -6 minus 12 minus 2, -18, -20. So we know that -20 is way down here. So I'm going to go ahead and just connect this. Okay. Now, also, don't forget, we still have to do domain and range on all of these, so you don't get out of doing domain and range. You're going to be sick of domain and range by the end of this year. And domain, we learned of quadratics, is always left to right, -infinity to +infinity. Range is always bottom. The bottom of this is going from -infinity up to the top, which is 4, and 4 is included. I think that's all we need now. Make sure you have these notes in class tomorrow, and we will practice more. Have a great night.